Alright, so polynomial function. That's what the most of this unit is really about. So that polynomial function. That was really just a review of things we've done in the past. So first, the form that it's going to be in is f of x. Remember, that's function notation.
Why is it making like a wave?
Yeah. That's what you
The
Oh, no,
why is
you're
it
right.
making a wave?
And I think it's
Why?
just really cool because math is so awesome like that.
No.
So a sub n just means that leading term. It's the first term. And then the next one is a sub n minus 1, x sub n minus 1. This is just putting it in order based on the highest degree to the lowest. That's why it's n minus 2 for the term, then n minus 2 at the top. So it's just reducing down.
Wait, so it's like a n minus and then x n minus 1 is wait, so it's a n minus 1 is a little thing, and then x n minus 1 is a thing itself.
Yeah, so this could be like x cubed. This would be x squared, and this would be x. So 3 is the n.
Okay.
And then this is just the coefficient. So let's say, like, this is just the general term. Okay, so if I actually put numbers in, let's say it was f of x. So it started with x cubed. So in here, what would the next term be? X
Square.
squared, so n minus 1. And then what would the next one be? And then the last one. Some constant, I'll call it.
Yeah.
And then the a sub n minus 1. Right here it's telling you these are the real numbers. A sub n cannot equal 0. Why can a sub n not equal 0? That is a real number though.
It has to be like a number that you use.
If I put 0 here, what would happen to that whole term?
It would just be like 0.
It would be 0 and then it wouldn't be there. That's what
I meant.
So, I'm sorry.
Okay,
A
so
real
I was
number.
making you
Like,
use real, like, yeah.
like it maybe can be 0, but like, is that really?
It's not really an age.
you solve the whole thing, there won't be a single 0 in it. At the
For
very
your coefficient, yeah. We'll never start with it. Now, it may not have the term here, and we'll talk about that later, but it may skip terms. And that would be where you have that A or that coefficient is 0. No negative exponents. So remember how before we were handling those negative exponents? As a polynomial function, you will not have negative exponents. Okay? A sub n is called the leading coefficient. Hopefully you've heard that term before back in Algebra 1. It just means the coefficient of the first term. Leading coefficient.
Wait, where are we now? This is
Algebra 2. Okay.
She's been in this math class the entire year. Wait, what is it again?
Alright, so we're going to go through and it's going to make a little bit more sense now when we have actual numbers. So instead of a sub n, you have negative 5. Okay. Alright, so first the degree. What's the degree of this first one? F of x equals 4. The exponent. The highest degree or the highest exponent. So it's just 4. There's no variable. It has to be 0. 0, very good. 0 degree. The leading coefficient is the coefficient of the first term. So what would the leading coefficient be?
4.
4, very good.
So where did this 0 come from?
There's no x there, so the degree is 0.
So like say if it was like x squared, it would be the degree is x squared.
2.
2? Oh, okay, yeah, that makes sense.
Abby, we're at the first page of the new set of notes. You don't have any notes. Alright, so then the second one, f of x equals negative 5x plus 1, what's my degree here? 1, very good. What's my leading coefficient?
Negative 5.
Negative 5, very good. This is easy, you guys were worried. Alright, how about the next one? What's the degree?
2.
2.
Oh.
2, 12, good. You know that part's funny. I don't realize it won't go
You're just ended there.
Let's go and do the next one. F of x equals negative x cubed minus x squared plus 8x plus 1. What's my degree? 3 and my leading coefficient. Negative 1, very good. Next one.
4. And negative 3.
Good. 5 and 9, very good. Fifth degree leading coefficient. What was, did it win in order?
It goes from 0 to 5.
Alright, everybody good with this idea? Pause a moment, let people finish reading. So if we talk about the parent function of a quadratic, the parent function would be y equals x squared. We have no coefficients other than 1, nothing's being added or subtracted, there's not that projectile motion, it's just the purest form. So if you talk about the parent function of a linear equation, that was y equals x. Does that make sense? Okay, so you have nothing added to it, you don't multiply by anything. If I want to grab a constant, so constant would be f of x, because we're in function, is equal to c, where c is just a value.
Would it go in like a straight line?
Yes, exactly, good job. So where would that straight line be?
Would
You could put it through 0, and it'd be horizontal.
yeah.
So let's say we had f of x equals 5. It would be graphed right along here.
So what's the number that is in the little box? What does that say?
F of x equals c. I just gave the parent function.
Would linear be up and down?
Not up and down. So
Diagonal.
linear. What's diagonal, right? So if I were to graph that, what's my slope?
Oh,
Slope is 1. What's my y-intercept? 0, because there's nothing being added. Remember the y equals mx plus b? So if you were to graph y equals x,
It'd be diagonal.
here, and you go up 1, over 1, up 1, over 1, it ends up being like that. Except it's dented, but it's a good straight line.
Well, I gotta hit up my my freshman math teacher again. So just like refresh this. Like she,
And remember all the stuff.
I had a
Alright, so now we have f of x equals x squared.
Would that be the one that goes like this? Like
Yes, a parabola, but it's going to go right side up. So the parent function of the quadratic starts at the vertex and it just kind of goes up like that. We could even do, remember we did the table? So if you weren't sure, you could do the negative b over 2a and it'd result in 0, 0. Negative 1, negative 2, 1, 2. If we were doing x squared, what would negative 2 be? 4. What would negative 1 be? 1.
4. 0.
That's the parent function. Okay. A cubic, what would the cubic equation be?
F of x equals x cubed.
Very good. So we're going to look at this one a little bit more.
Is
Because
it a squiggly line?
it does make a bit of a squiggly, I think I know what you mean. But let's go ahead and do a table. When it's a parent function, we're always going to have 0 in the middle. Well, if I plug in 0, what's my y value? So we'll still go down 1, down 2, up 1, up 2. Go ahead on your own. Negative 1 cubed. What's negative 1 cubed? Negative 1, right. What is negative 2 cubed? Negative 8, right. So, that's okay. Alright, so we have negative 8, negative 1, 0 so far. What is 1 cubed? 1.
Positive 8.
Positive 8, right. So did you see what happened here? The quadratic mirrored each other. This one, they're opposites on either side in the parent function. So we have negative 8, negative 1, 0, 1, 8. So if I were to graph this, I know there's not numbers on it, so we're just going to estimate. If I'm over at negative 2, come down to negative 8. And then negative 1, negative 1. Oh, right there. 0, 0. And then we have 1, 1.
Oh, that's the one where it goes up and
Is this what you're thinking of?
Yeah.
So it's kind of like a business graph or whatever. No, like
Like with the profits and the
Yeah.
losses and all
Yeah.
that, yeah. I see what you're saying.
I think at this point I've spent like a collective like 4 hours.
Oh dear.
You need to have like a comedy show, just like all the funny
The
things.
post Cameron says.
Yeah.
I met my friend.
Cameron,
She's the funniest.
Let's go ahead and do quartic and quintic on the next page. We're in the notes. Here's the notes would be the parent function for the quartic. It would be. So we're going to do f of x. Alright, we're going to make our table. We're going to do negative 2, negative 1, 0, 1, 2. We're going to plug it into that parent function. Negative 2 to the 4th, what would that be?
16.
It would be positive 16, very good. Because remember, it's a negative number to an even exponent, so positive. Negative 1 to the 4th. 1, very good. How about 0 to the 4th?
0.
And then positive 1 to the 4th.
1.
and then positive 2 to the 4th.
That would be 16.
It would be positive 16. Alright, so now when we graph this, you can tell it's going to make a sharp turn up. So 16 typically isn't on our graph. So I'm going to start with -1, I come up to 1, I have 0, 0. Positive 1, 1, and then I know it's going to go pretty much straight up. Not straight up, but steeply up. So it looks like a quadratic, right? But it's going to raise quicker, depending on the other numbers, but the parent function is going to go up quicker than the quadratic.
That one graph we just did before this one, the cubic,
Yeah.
is that used for like stocks and stuff?
I would have to look that up.
Oh, okay.
I have a feeling those are tracking actual losses, so it probably could be mirrored by a cubic, but they're tracking their losses and gains.
My boyfriend's in stocks now, so no.
Alright, how about quintic? What would that one be? Hi, so we have alpha of x. X to the 5th. Let's go ahead and make another table. So we have x and y. We're still going to do -2, -1, 0, 1, 2. What's -2 to the 5th?
Negative 32.
It is -32. -1 to the 5th.
One.
-1. Because it's a negative number to an odd exponent will remain negative. 0 to the 5th. 1 to the 5th. 2 to the 5th. Alright, so notice that it looks similar to that cubic parent function, where it mirrored each other except they're opposites. So it's still going to do this. What's that?
Is it just going to be sharper?
Sharper, exactly. So you're going to be way down here. I'm going to go ahead and do my -1, -1. I have 0, 0, and I have 1, 1. So those should be in line as if they're linear, but we know obviously it's not. So it's going to come from way down there pretty sharply and then curve and go up pretty sharply. So very similar to the cubic, however, it's going to be a quicker rise and fall.
That's pretty sure.
Pretty sharp. Alright, that wasn't too bad, was it? What I want you to do for homework. I'm going to explain the homework real quick. You guys have access to Desmos, right?
Maybe.
Maybe. What I want you to do on Desmos, I'll do the first one with you, but I'm going to have you fill this in. When you graph this, what this is asking is as x goes to positive infinity. So as x goes to the right, so to the right of the graph, what's happening to the f of x or the y values? Is it going to positive or negative infinity? Well, we'll graph it and we'll see. You don't have to go. And then as it goes to the left, so negative infinity, so it goes to the left, is it going to positive or negative infinity? So go ahead and get out Desmos.
They're NGNT, right?
That's right.
Oh,
Right.
oh.
Do you guys remember the graph? As the graph moves to the left, what's happening to the y values? Positive infinity again.
As long as it goes up, it's positive.
Exactly. So if it goes down, you would say negative infinity. So I want you to do that. You can use your phone or your computer. If your homework is to do that for each of these graphs, do it in pencil and then we'll come back and look at it.
So just the homework is 2, 4, 6, 3, 5?
Yes. Just determine if it's, and you're just graphing it. You're not doing it with a table right now. I'll show you that tomorrow. You're just graphing it using Desmos. So tell me if it moves to the right, is it going up or down, basically? If it moves to the left, it's going up and down. But use that positive infinity and negative infinity notation.